Hey everyone, this is Andy Melbuff, and this video is going to take a look at using Desmos Activity Builder to incorporate open middle concepts in mathematics. Specifically, we're going to see a template here that has something called a Spinequality on it that we're going to use to adjust or make adjustments to ask students to show connections or to satisfy certain conditions. Now, this particular open middle concept involves subtraction of two-digit numbers, and we want to see if the students can get something to work that's correct. So showing you in preview mode, and also up here I want to point out for those working remotely, right now this is what would show on the teacher dashboard because a student is incorrect with what he or she has presented up to this point. So if we go ahead and drag numbers in here, now, if I want to make this correct, I want to pull a 5 into the box. Keep an eye on this correct check up here. As soon as the 5 goes in there, the teacher sees this, the students do not. And as soon as all 6 boxes are populated with numbers, the student has an option to check their work. And so when they click that button, there's a process that goes through here where the buttons are checked, and there's some feedback indicated by this green check mark and this Spinequality, which basically says this two-digit number minus this two-digit number is equal to the 15. Now, let me reset it and show you what would happen if the student doesn't have a correct answer at the end. Let's say they take the 5 out and they put in a number that's too small. So as soon as this number goes in here, this teacher dashboard thing goes from a check to an X, indicating it's wrong. And watch what happens to the equal sign, the Spinequality, when we press check my work. This shows that the left-hand side of the equation is bigger than the right-hand side. It's not actually an equation anymore. And they also get this red X as a piece of feedback. So how can we make this happen with maybe some different types of scenarios other than this exact one? Well, we have to go into the edit feature to see this. Now in edit mode, what I would suggest doing first is making a copy of the slide that you want to adjust or manipulate. So I'm on screen number 1 here, and to make a copy, I'm going to go over here to the 3 horizontal dots. I'm going to duplicate this screen. So now this screen number 2 that I'm on is the exact same as the previous, and then I want to make an adjustment. Let's say I want to change my equation to go from what it is now to having a two-digit number minus a single-digit number, and then I want that to be equal to another single-digit number. So I have some manipulation to do here. So I'm going to click Edit to go into this graph component. Now what you see across the top here are 6 boxes. I'm going to call them boxes. We're going to call them box 1, box 2, all the way to the end, left to right, boxes 1 through 6. Those boxes are created on the left-hand side in this boxes folder. Opening the folder, we do not want to do anything with lines 2 or 3 in here. That's the coding that creates the box. What we do want to pay attention to is in line 5, because we have a table in line 5. And basically, the ordered pairs in the table create the locations of the 6 boxes. To see that visually, I can turn on the table ordered pairs by clicking this open circle. You'll see on the right-hand side, little purple dots appear on the bottom of each box. These are now movable. I can drag them manually, and you'll notice also as I drag this that the ordered pair in the top of the table on the left is changing based on the location I drag it to. I can drag it back to where I started, and it's pretty close, but I'll just leave it there for now. I can also adjust its position in the table. For example, this 2.5 is a y coordinate. If I make it 1.5, you'll notice my box moved. If I make it simply 1, my box moves again. So I'm going to put it back to 2.5 just so that you can see that we can manipulate box locations simply by editing in the table or by doing the dragging of the dots. Well, let's revisit what we were going to focus on before. I want a two-digit number. Drag this over a little bit, make it -4. And I want a two-digit number minus a single-digit number. So I need 2 of the boxes to go away. Well, what I'm going to do is simply take out my last 2 rows in the table. I'm going to delete them, backspace through them, however you want to handle that. I now have 4 boxes, but I want box number 4 to be on the right-hand side of the equal sign, so I need to move it further to the right. Moving it to the right, there's a little bit of guess and check involved here, okay? If I change that to 1.75, it moves it a little bit. 2.75, that's pretty close. I'm going to make it a value of 2, and then I'm going to move my equal sign. Well, the equal sign is a symbol, but it's a special symbol. It's called a Spinequality. So what I'm going to do is I'm going to leave this boxes folder for a minute, and I'm going to go down here to the Spinequalities folder. And again, most of this folder you're not going to touch. You're just going to leave it alone. But you're going to find the one function that's being graphed right now, and it's in green, so it kind of stands out, and that's the Spinequality function here. And the way this is set up is this. This first value I'm highlighting is the x-coordinate of the Spinequality. The second one is the y-coordinate. So this equal sign is at coordinates 1.9, 3. It's got a scale value of 0.5. That's basically the size of it. And then t is my component at the end. We don't do anything with t. And what we're going to do is change the location of that by moving it left. I want to move it left of 1.9. Let's try 0. Well, 0 is an x-coordinate. It's too far. Let's try 0.5, getting closer. And there's a little bit of manipulation involved here, a little bit of guess and check to get it right where you want it to go. But that's pretty close. I'm comfortable with that. So I'm going to close out of this Spinequalities folder. And then I want to make sure my symbol's in the right spot. So it does look like it is this subtraction symbol, but let me show you how to change it if it's not. I'm going to go into my symbols folder, and I can create any of these types of symbols I want. These equations right here, I'm highlighting it. It's very long, okay, and it's very sophisticated looking. And the good news is you don't have to do anything with it. All you need to be able to do is recognize that I need to pick out which one of these I want to work with. So I'm going to show you how to create a subtraction symbol. And maybe I want to do an addition symbol. Let's change it to addition. So if I want an addition symbol, notice here what's in red is this subtraction symbol. I'm going to delete this box, and I'm going to simply add a new expression. And if I want an addition symbol between them, I'm going to use S sub add. Leave the subscript, and then I need my format. I need an x comma y ordered pair. Well, where do I want that to go? And maybe we're not sure where we want it to go. Type in some numbers. I'm going to type in -2 as an x, 3 as a y. I need a scale. I initially start with a scale of 1, and then I'll put in a t component. Well, it comes in as blue, and it's not too far off, actually, from where I want to put it. But I want to move it further to the right. So instead of an x-coordinate of -2, I might use an x-coordinate of -1. Oop, that's not going to work. Maybe -1.5. That's pretty close. -1.8. We're getting closer. That's real good right there. I can change its color here by changing colors like I do normally in Desmos. I'm going to go ahead and make it red again. I can make it thicker or stand out more by changing the line thickness. It comes in as a default of 2.5. I like defaults of 6, just it makes it stand out a little bit more. And so now maybe I'm ready to go here. So that's how I create a symbol. But originally I said I wanted to do 2-digit minus 1-digit. So if I want to change a symbol, I can simply get rid of the add subscript and make it subtract, and then changes it to a minus sign. And again, the mathematical computation behind all that is in boxes 8 through 13. You don't need to worry about that. Just leave that stuff alone. So also, if we're changing the type of problem we're doing, we need to change the correct check. So I'm going to go down here to the correctness and feedback folder. It was already open, but I'm going to open it and close it and just show you how that works. Most of this we are not going to touch. But what we are going to touch is down here in box 96. And that's how we determine Is it correct? The symbol I sub c is what Desmos typically uses for is correct. It's a setting a variable there, if you will. Well, to think about two-digit subtraction, two-digit numbers minus one-digit numbers, we have to think about what that means mathematically. Well, when I have a two-digit number, what that really means is I have 10 times the first digit. Well, what the first digit is, mathematically here in this activity builder, is z sub 1. That means box sub 1. So we want 10 times box sub 1 plus box sub 2, and then we're going to subtract something from it. Well, in our previous example, we had another two-digit number. So I subtracted 10 times box sub 3 plus box sub 4. But now I don't have a two-digit number. I have a one-digit number. So I don't want the 10 times box sub 3. I just want box sub 3. So I'll do this, and I don't need a box sub 4 anymore with that particular expression. Now on the right-hand side, I want a box sub 4, but not multiplied by 10. So I'm going to get rid of the 10. I'm going to change the subscript to 4. And I'm going to get rid of box sub 6. And at this point, what this is basically saying is, here's our first two-digit number. I'm going to subtract a single-digit number, and I want to know, is that equal to box 4? If that's all true, 1 is assigned to be the value of I sub c. In other words, I sub c that is correct will be assigned a value of 1. If it's not correct, it'll be assigned a value of 0. So that's necessary for our correct check. I'm going to close this folder, and then I need to get into the computation layer and do something very similar with that. The computation layer here has some stuff that some of it will need to be changed, some of it won't. The first part I want to focus on is this part right here in the middle, where we define variables LHS and RHS. LHS represents left-hand side. It's calculating the left-hand side of our proposed equation. RHS calculates the right-hand side. And I'm going to do something here very similar to what I did in the previous screen. I'm going to look at setting what the value numerically of that left-hand side will be. So I'm highlighting this right here. This represents box 1. And do I want to multiply it by 10? Yes, we do, because it's a two-digit number. Do I then want to add it to box? All right, I have to undo that. I have to then add it to box sub 2. So no change necessary there. Am I subtracting still? Yes. But then after the subtraction symbol, I don't want 10 times box sub 3. So I'm going to get rid of the 10 times. I don't want to add to it box sub 4. So I'm going to do that. So that changes how the left-hand side of my proposed equation is being calculated. The right-hand side has a similar change necessary. It's a single-digit number, so I don't want 10 times box sub 5. In fact, I don't even want a box sub 5. I want a box sub 4. And I don't even want a box sub 6. So I'm going to get rid of that completely. Luckily, no error symbols. That's good. And I also need to slide down a little bit lower to the correct check, the dashboard symbol that shows if it's correct or not. Since I'm only using 4 boxes now, this is saying I'm only going to check and see if 4 of those are correct. So I need to delete these 2. And this is now what's being checked. So I'm going to click Done. I need to go into my button component, Computation Layer, and do the same thing with my disabled features. I want to get rid of boxes Z5 and Z6. Make a similar change there. Now let's take a look in preview mode. Here's what we had hoped students to fill in. I already can tell I already made a mistake. See these purple dots? I don't want them in there. I forgot to turn my table off, and that table's located under boxes, so I'm going to do that. And also I might want to reposition this, drag it a little bit, blow it up just a bit. You can do whatever you'd like there. Let's take a look in preview mode. All right, two-digit number. Let's try 12 minus 3. As I start dragging in, you'll see the dashboard check is an X. 12 minus 3, 9. Dashboard check now because I have a correct equation, but the student doesn't see that until they check their work. The Spinequality and the feedback shows them they're correct. Showing this incorrectly, dashboard check, nope. Check my work. Oh, the left-hand side is greater than the right-hand side. Well, what if here, let me reset it. I want to show you it spinning the other way. Ten minus 7, incorrect. Check my work. There's it spinning the other way. So that's a little bit of how you can make the Spinequality template work for your particular version of an open middle concept.